So again with another video, we have come to discuss vancomycin intermediate Staphylococcus aureus and vancomycin resistant Staphylococcus aureus. In earlier video, we had read a comment that there is a kind of emergency situation because vancomycin intermediate and vancomycin resistant strains of Staphylococcus aureus, along with common methicillin resistant Staphylococcus aureus, are being reported. So how do VRSA or vancomycin intermediate Staphylococcus aureus and VRSA vancomycin resistant Staphylococcus aureus get their names? Staph bacteria are classified as VRSA or vancomycin resistant Staphylococcus aureus based on laboratory tests. Laboratories perform tests to determine if Staphylococcus aureus bacteria are resistant to antimicrobial agents that might be used for treatment of infections. For vancomycin and other antimicrobial agents, laboratories determine how much of the agent it requires to inhibit the growth of the organism in a test tube. The result of the test is usually expressed as a minimum inhibitory concentration MIC, or minimum amount of antimicrobial agent that inhibits bacterial growth in the test tube. Well, that's how minimum inhibitory concentration test works, right? Therefore, staph bacteria are classified as VRSA, vancomycin intermediate Staphylococcus aureus, if the MIC of vancomycin is 4 to 8 microgram per ml, and classified as VRSA if the vancomycin MIC is more than or equal to 16 microgram per ml. So are VRSA and VRSA infections treatable? Yes. As of October 2010, all VRSA and VRSA isolates have been susceptible to several FDA-approved drugs. At the time of introduction of penicillin in early 1940s, Staphylococcus aureus was uniformly susceptible to this drug. However, widespread resistance to penicillin developed during 1950s, followed in the 1970s by increasing resistance in the new semi-synthetic penicillinase resistant antimicrobial agents like methicillin, oxacillin, nafcillin, dicloxacillin, etc. By 1990s, resistance to penicillinase resistant penicillins had spread throughout the world, compromising the use of these drugs for empiric therapy for staphylococcal infections. This has led to increased reliance on vancomycin for treatment of documented methicillin-resistant Staphylococcus aureus infections, as well as for empiric therapy for infections in populations where the prevalence of MRSA is high. Reports in 1990s suggested that the susceptibility of Staphylococcus aureus to vancomycin was changing. In May 1996, the first documented infection with vancomycin intermediate Staphylococcus aureus, that is VRSA, minimum inhibitory concentration is 4 to 8 microgram per ml for VRSA, was reported in a patient in Japan. So the first VRSA was reported in Japan in 1996. So subsequently, infections with VRSA strains have been reported in patients from the United States, Europe, and Asia also. To date, all VRSA examined have had non-transferable resistance mechanisms, which are not maintained in the absence of vancomycin. Furthermore, expression of the VRSA phenotype appears to have substantial fitness costs for the organism. For these reasons, VRSA are considered less of a public health threat than VRSA. However, VRSA is still clinically important, and laboratories should ensure that treating physicians and infection control are notified of vancomycin intermediate Staphylococcus aureus per facility policy. As of May 2015, 14 VRSA infections have been reported in patients from the United States. This data might have changed as we are discussing this in 2024. You may consider Googling for the newest data. All VRSA described to date have acquired the VAN-A vancomycin resistant gene. The VAN-A gene is the vancomycin resistance gene, and operon, commonly found in vancomycin resistant enterococci (VRE). VRSA is thought to result from specific precursor organisms, MRSA containing the PSK41 type plasmid and VRE containing VAN-A encoded on INC18 like plasmid. Geographic clustering has been observed among US VRSA patients, with 8 of 10 VRSA documented from 2002 to 2009 occurring in patients from Michigan, and all 4 VRSA infections since 2010 occurring in patients from Delaware. This may be due to a higher prevalence of VRSA precursor organisms in some areas. No VRSA transmission has been documented till. When VRSA is identified in a clinical laboratory, laboratory personnel should immediately notify the patient's primary caregiver, patient care personnel, and infection control so that appropriate infection control precautions can be initiated promptly. Notifying local and state public health departments is also important. These notifications should occur when waiting for VRSA confirmatory testing. Since VRSA is not so common yet, it should be notified to local and state public health departments, and it should be confirmed by a reference laboratory. So Staphylococcus aureus isolates with a vancomycin minimum inhibitory concentration of 8 microgram per ml or higher should be submitted to CDC for confirmation of susceptibility results. Vancomycin resistant Staphylococcus aureus, that is vancomycin MIC of more than or equal to 16 microgram per ml, is to be suspected or confirmed. CDC requests that all VRE, MRSA and VRSA isolates from the patient to be saved to allow characterization of VRSA precursor organisms. After confirmation of VRSA, these organisms should be shared with public health partners, including CDC itself. CDC definition for classifying isolates of Staphylococcus aureus with reduced susceptibility to vancomycin are based on laboratory breakpoints established by Clinical and Laboratory Standards Institute (CRSI). The CRSI breakpoints for Staphylococcus aureus and vancomycin were last modified in 2009. So, vancomycin susceptible Staphylococcus aureus is when vancomycin MIC is less than or equal to 2 microgram per ml. Vancomycin intermediate Staphylococcus aureus VISA is when vancomycin MIC is 4 to 8 microgram per ml for that bacteria. And vancomycin resistant Staphylococcus aureus VRSA is when vancomycin MIC is more than or equal to 16 microgram per ml for that Staphylococcus aureus isolate. So here is one definitional note. The breakpoint of Staphylococcus aureus and vancomycin differ from those for other Staphylococcus species. This means other Staphylococci than Staphylococcus aureus, the breakpoint for vancomycin would differ. So laboratory surveillance and diagnostic issues. Testing difficulties. Detecting emerging antimicrobial resistance in bacterial isolates can sometimes be problematic, especially in highly automated clinical microbiology laboratories. In the following section, we describe some steps laboratories may take to improve their ability to detect emerging vancomycin resistance in Staphylococcus aureus. So, testing recommendations. All automated susceptibility testing systems currently approved for use in the United States can reliably detect VRSA. In addition to automated systems, VRSA isolates are detected by reference growth microdilution, agar dilution, gradient diffusion, and vancomycin screen agar plates. Brain heart infusion agar containing 6 microgram per ml of vancomycin is known as the vancomycin screen agar plates. And this diffusion is not recommended for testing vancomycin susceptibility in Staphylococcus aureus for reasons that are described below. So, VA vancomycin intermediate Staphylococcus aureus can be detected by automated MIC methods. Although many commercial AST systems and gradient diffusion tend to produce vancomycin MICs that are 0.5 to 1 doubling dilution higher than reference method. That is growth microdilution or agar dilution. Vancomycin, it means the reference methods are growth microdilution and agar dilution, and the automated MIC methods, they are seen to produce vancomycin MICs that are 0.5 to 1 doubling dilution higher than the result produced by these reference methods. Vancomycin intermediate Staphylococcus aureus are not detected by this diffusion method because zone diameters produced by vancomycin susceptible and vancomycin intermediate Staphylococcus aureus strains are indistinguishable. That's why this diffusion method for detecting VISA or VISA is not considered a good method. Right? Vancomycin screen agar plates usually detect VISA for which the vancomycin MICs are 8 microgram per ml. So if the MIC is 8 microgram per ml or more, then only vancomycin screen agars can usually detect VISA. But further studies are needed to define the level of sensitivity of these methods for Staphylococcus aureus, for which vancomycin MIC are 4 microgram per ml. Testing algorithm. In addition to knowing the appropriate testing methodologies, all laboratories should develop a step-by-step problem-solving procedure or algorithm for detecting VRSA specifically for their laboratory. All Staphylococcus aureus strains for which vancomycin MIC is more than or equal to 4 microgram per ml are unusual and should not be discarded until the MICs have been confirmed by a validated method. In addition, laboratories should ensure that the strain is in pure culture and confirm the organism identification. If retesting confirms identity, purity, and vancomycin MIC more than or equal to 4 microgram per ml, laboratories should notify the infection control. For isolates with an MIC of more than or equal to 8 microgram per ml, laboratories should also inform the local and or state health department, if required, as well as the Division of Healthcare Quality Promotion, as well as the Division of Healthcare Quality Promotion at CDC by sending an email to haioutbreak@cdc.gov. This is the email address that can be used to notify the Division of Healthcare Quality Promotion at CDC. If vancomycin MIC of more than or equal to 8 microgram per ml has been detected, the isolate should be sent to the health department and or CDC for confirmation by a reference method. So the isolate sent would be confirmed by CDC by using a reference method. And if the isolate is confirmed by CDC to have reduced susceptibility to vancomycin, that is MIC of more than or equal to 8 microgram per ml, CDC will work with the public health department, including the state antimicrobial resistance program and infection control personnel, to address any local infection control issues, and the health department to address broader public health implications. So once notified to the CDC, the CDC will confirm the results and take actions. So recommendations. So testing algorithm using vancomycin agar screen plates would be the vancomycin agar screen test uses commercially prepared plates containing both brain heart infusion agar and 6 microgram per ml of vancomycin to screen pure cultures of bacteria for vancomycin resistance. Commercially prepared plates that contain VHI agar and 6 microgram per ml of vancomycin may be used for screening. So commercially prepared plates are preferred because adequate quality control of the agar test medium is critical. And in studies conducted at CDC, some lots of vancomycin containing BSI agar prepared in-house were less specific than plates prepared commercially and allowed growth of susceptible quality control strains. A 10 microliter inoculum of 0.5 McFarland suspension should be spotted on the agar using a micropipette. Final concentration 106 colony forming units per ml. Alternatively, a swab may be dipped in 0.5 McFarland suspension. The excess of liquid is expressed out and it is used to inoculate the vancomycin agar screen plate. For quality control, laboratories should use Enterococcus faecalis ATCC number 29212 is the susceptible control and Enterococcus faecalis ATCC 51299 is the resistant control. Remember, Enterococcus faecalis ATCC 29212 is a susceptible control and Enterococcus faecalis ATCC 51299 is the resistant control. Up to 8 isolates can be tested per plate. Quality control should be performed each day of testing. And growth of more than one colony is considered a positive result. All Staphylococcus aureus isolates for which the vancomycin MIC more than or equal to 8 microgram per ml grow on these plates, and some isolates for which the vancomycin MIC is equal to 4 microgram per ml will also grow. Some of the isolates whose MIC for vancomycin is 4 microgram per ml will also grow, and all of the strains with vancomycin MIC of 8 microgram per ml will grow on these agar plates. Ultimately, all staphylococci that grow on these plates should be inspected for purity, and the original clinical isolate should be tested using FDA cleared MIC method for confirmation. So confirmatory testing method used by CDC is described here. So CDC defines Staphylococcus aureus strains as a vancomycin intermediate Staphylococcus aureus or vancomycin resistant Staphylococcus aureus based on the MIC for vancomycin obtained by reference broth microbial dilution. Additionally, CDC tests all presumptive VRSA or VRSA isolates by gradient diffusion also. Isolates confirmed as a VRSA at CDC are further examined by PCR. So email can be sent to haioutbreak@cdc.com for information on how to send isolates to CDC for testing. So the technique, reference broth microdilution, and if vancomycin MIC is more than or equal to 16 microgram per ml in cation adjusted Muller-Hinton agar broth, then it's considered VRSA. If vancomycin MIC of 4 to 8 microgram per ml is obtained in cation adjusted Muller-Hinton agar broth, not agar, Muller-Hinton broth, then vancomycin intermediate Staphylococcus aureus is considered, and before reading the results, it should be incubated fully up to 24 hours. So in case of commercially prepared brain heart infusion agar containing 6 microgram per ml of vancomycin, the growth of more than one colony in 24 hours is considered vancomycin resistant, and growth of more than one colony in 24 hours could also be vancomycin intermediate Staphylococcus aureus. So 2 or more colonies is a positive result. For quality control is already mentioned, Enterococcus faecalis ATCC 29212 is a susceptible control, and Enterococcus faecalis ATCC number 251299 is a resistant control, should be used for each plate of testing, right? So in gradient diffusion or e-test, vancomycin MIC of more than or equal to 16 microgram per ml on molar intent agar is considered vancomycin resistant agar, while vancomycin MIC of 4 to 8 microgram per ml on MHA is considered vancomycin intermediate results. So use of a 0.5 mac per land standard to prepare the inoculum suspension is recommended, and it should be incubated for full 24 hours because before the results are read. Thank you very much.